Okay, so I'm gonna mix a few videos just to have the core notes for the circle unit that we have had the last week or two. Do pay attention because I'm rearranging the content to make these videos shorter, so I'm not following the lesson notes that we've had in class. So please be aware of that. But all the core information should still be there. So this first one, part one for these circle videos, I just want to go over some vocabulary, formalize a few, and then just make sure we're on the same page for some others. So first up, by definition for a circle, it is all points that are equidistant from a given point called the center. Okay? The idea behind that is if you give me a center and you make all points that are equidistant to that center, I realize mine is a little lopsided, the center should be moved over. I can define that center to be, I don't know, we'll call it P. And then if I know the distance from that center to my circle, then as long as I keep that same distance all the way around, I have defined my circle. The advantage is that that means all I need is a center and a distance, otherwise known as the radius, in order to define any circle. From a naming standpoint, I would have the option, if I was writing a statement about this picture, to either call it circle P, or shorthand wise, you could use a circle with a dot in the middle, and this is another way of claiming it to be circle P. In addition to circle P, I'm going to talk about some line segments and then some angles that are associated with our circles. So first up, from line segments, I could have what's called a chord. And a chord is a line segment with endpoints on the circle. Okay, so if I draw a circle right here, I could have chord AB, and it clearly has endpoints on the circle. I could also have chord EF, and it also has endpoints on the circle, and both these would be chords. I could draw any going any which way, and they, as long as endpoints are on the circle, it is a chord. In addition to a chord, we can get more specific and have a diameter. And a diameter is a chord that passes through the center. Okay? So for example, up here, while AB and EF are both chords, we could only specifically say that EF is a diameter. Okay? So that's the idea there. Diameters are special cases for chords, ones that specifically go through the center. Now our segments don't need to stay inside of our circle. We also have what's called a secant line, which could be a line, segment, or ray, which passes the circle in two spots. And so the idea here is now it's no longer defined to just stay in the circle, but now extends outside. So I might have something that looks like this. That would be a secant segment. Now the moment I put little arrows on the end, all of a sudden I've got a secant line. So if I call this A and B, I would say that this would be AB is a secant line. Okay, so we've got this idea here where we've got a secant line. In addition to our secant line, let me just zoom in a little bit. Okay, in addition to our secant line, we could also have what's referred to as a tangent line. While they're connected, it is not a direct connection to the tangent that we know from SOHCAHTOA. This is one of those cases where there's kind of two definitions for words, but there is the option to kind of relate them, but it's a conversation for another day. But this tangent is also a line segment. Usually it's a line, but technically maybe these line segment array, which passes the circle in exactly one point. Doesn't cross twice, crosses once. So if I draw my circle right here, I've got that. A tangent would do something like this. And again, I could put some arrows on it. Maybe I call it line L, and we would say that line L is a tangent line. It crosses my circle at exactly 1 point. Okay? Now, I'm going to go ahead and front load that one of the key details with that tangent line is if I were to draw in this radius, that radius and that tangent line will meet at a right angle. And that gives us a huge advantage for solving some problems, because that means every time I've got a tangent line, I've got an automatic right angle, I've got an automatic right triangle I can draw potentially in my shape. So that's just something to be aware of. Okay? So those are some line segments related. I'm going to jump over, we're still talking some circle vocabulary, but I'm going to jump over and cover some angle measures. So the first one I have is called a central angle. Let's see where it's top of my paper. It's right there. Perfect. Okay. So central angle is an angle whose vertex is on the center and passes through the circle. So if I've got my circle, got my center, an example of a central angle would be something like this. Okay, my vertex is on the center and my rays extend all the way to the edge. So if I label this A, B, C, angle A, B, C is central. If I were to move that vertex anywhere, let's say my vertex was over here in no man's land, call it DEF. Angle DEF is not central. Okay, so that key is that vertex is on the center. We're going to talk about the angle relationships for these kinds of problems in a little bit, but that's enough to get you started. In addition to a central angle, we have what's called an inscribed angle. And an inscribed angle is an angle whose vertex is on the circle and passes through the circle. Realize the second part might not be clear. I'm referring to the rays or the sides of the circle or angle passing through. So right here, what I mean is if I've got a circle, I need to have a vertex on the circle. Notice where I put, can't see that. Notice where I put that first red dot, and then I'm going to extend my rays or sides of my angle until they cross the circle. So right here, I could call this GHI, and I would say that angle GHI is an inscribed angle. The vertex is on the circle, and the sides or the rays extend through the edge of the circle. The last definition that I'm going to talk about for this first round of circles pertains to both these sets of angles, and it's the idea of the following. We have what's called an intercepted arc. And it is the piece of the circle that is inside an angle. Okay, so for example, I could have a central angle I could call that A, B, C, and so central angle A, B, C has intercepted arc comma, go to black, AB, and it's referring to this space right here. That intercepted arc, the part that gets cut by my angle, is going to be arc AB. Okay? By the same token, if I had an inscribed angle right here, GHI, inscribed angle GHI has intercepted arc in this case it would be GI. It's the distance between the sides of my angle, and it'd be that arc piece that's being cut off. Now to talk about arcs real quick, because I think I can finish this up. I know this is a longer video. Please keep this in mind. Arcs are measured in degrees. Arcs are measured in degrees. You always take the shortest path between 2 points when naming an arc. So for example, let's just put A, B, C right here. If I told you I was interested in arc AB, right? Then I would have to take the shortest path from A to B. So if I start here at A, I'm going to travel over here to B. And that would be equal to arc AB. Now, since AB is less than 180, it is called a minor arc. Okay? Now suppose I wasn't interested in that piece, but I really wanted to talk about the rest, and I really wanted to go from A all the way around to B. Suppose that's what I was interested in. If that's the case, I need the third letter. So I would call it as being ACB. I'm traveling from A to C and from C to B. So this is read arc ACB. It's more than 180. And so we would refer to it as a major arc. Okay, so there's a bit of a crash course. We've got angle relationships, arc relationships, and some side vocabulary, not relationships. The next few videos will cover the relationships.